In this video, we're going to discuss factoring when we have the difference of two perfect squares. As we've discussed in previous videos, a perfect square is some number, like the number 4, where we could find one number that if we multiply by itself, it'll give us 4. So if we have 2 times 2 is 4, so 4 is a perfect square. Let's say we have 16. If we have 4, we can multiply 4 by itself. 4 times 4 is 16, so 16 is a perfect square. When do we have a variable that's a perfect square? Let's say we have the square root of x to the 6th. Whenever we have a variable with an even exponent, we just take a half of that exponent, and that's our answer. So the square root of x to the 6th is x to the 3rd, and x to the 6th is a perfect square. In this video, we're going to discuss factoring when we have the difference of two perfect squares. For example, let's say we have x squared minus 36. This is the difference of two perfect squares. Because we have one perfect square, which is x squared, a variable is always a perfect square if it has an even exponent, which this one does, and 36 is a perfect square. If you don't know that, you could do that on your calculator. 36 is a perfect square, so if we multiply 6 by 6, it'll give us 36. And the difference, we have the difference of perfect squares because there's a minus sign between them. Now, how do we factor this? In the last video, we discussed factoring using a GCF. But in this case, there's obviously no GCF because the coefficient of x squared is just 1. So the biggest number we could factor out would be a 1, which we don't bother factoring. We only factor out numbers that are greater than 1. And we can't factor out a variable because 36 is a constant. It has no variable term. So what do? We can use something called the method of using the difference of two perfect squares. When we have two perfect squares, like we have here, x squared and 36, and they're separated by a minus sign, it's very easy to factor them. All we do is, we take the square root of the first one, and we do plus the square root of the second one, and we multiply that by the square root of the first one, minus the square root of the second one. So the square root of x squared is x. So we do the square root of x squared, which is x, plus the square root of the second one, and the square root of the second one, the square root of 36 is 6. Then we multiply that by the square root of the first one, the square root of x squared is x, and we subtract from that the square root of the second one, and the second one is 36, so the square root of 36 is 6. And let's see if we got it right. We're going to use the method of FOIL to multiply these two binomials and see if we get back to our original question. So we're going to multiply the first terms. X times x is x squared. The O is for outer. X times negative 6 is negative 6x. We're going to multiply the inner terms. 6 times positive 6 times positive x is plus 6x. And the last terms, 6 times negative 6 is negative 36. Let's combine like terms. We have an x squared with no like term. Negative 6x and positive 6x cancel each other out. So we're left with x squared minus 36, which was our original question. So that answer is correct. A trick question you might see is when they give you x squared plus 36. And you cannot use the method of the difference of perfect squares for this because you don't have a difference. You have a sum. The difference of perfect squares, even though x squared and 36 are both perfect squares, you can't use the method of difference of two perfect squares because this is not a difference, this is a sum. Let's try another example. Let's say we have x to the 4th minus 64. Now you might notice right away this is the difference of perfect squares, but even before you do the difference of perfect squares, you want to see if there's a GCF. In this case, there is no GCF, so let's move on to the difference of perfect squares. You take the square root of the first one, so the first one is x to the 4th, and the square root of x to the 4th is x squared. You do x squared plus the square root of the second one, The second one is 64. The square root of 64, if you don't know, you can do it on your calculator, but it's 8. Then you're going to do the square root of the first one, which is x squared, minus the square root of the second one, which is 8. And this is your answer. This is the factored form of this binomial. And let's FOIL back to make sure we got it right. We're going to do first, outer, inner, last. So we multiply the two first terms by each other. X squared times x squared is x to the fourth. Outer is x squared times negative 8, which is negative 8x squared. Inner is 8 times x squared is 8x squared. And then last is 8 times negative 8 is negative 64. Let's combine like terms. X to the fourth, there's no like term, but we have negative 8x squared plus 8x squared. These two cancel out. We're left with x squared, x to the fourth minus 64, which was our original equation, so the answer is correct. Let's try another example. Let's say we have 4x to the fourth. Actually, let's do 4x squared minus 4. The first thing you always want to do, even if you see that's a difference of two perfect squares, you always want to check, is there a GCF? And in this case, there is a GCF. We have a GCF of 4. So we're going to take out that 4, and we're going to rewrite the question as x squared. So we divide the 4x squared divided by 4, which is x squared. We divide the negative 4 by 4, which is minus 1. And you might just leave your question like this and circle it or box it in and say this is your answer. But that is not the answer. If they want this in completely factored, this is not the answer. How come? Because we still have within the parentheses the difference of two perfect squares. X squared is a perfect square. 1 is a perfect square because 1 times 1 is 1. And we have a minus sign between them. So inside the parentheses, we still have the difference of two perfect squares. So we're going to have to factor this more. We have to keep our 4 there. And then we're going to make our parentheses. And in the first one, we have the square root of the first term, which is x squared. The square root of x squared is x. The square root of 1 is 1. The square root of the first term is x. Then we do subtract the square root of the second term, which is 1. And is there anything else we could do? Now, you might think that you could do the difference of perfect squares again, but you can't do it on x minus 1 because x is not a perfect square. So this would be your answer. You want to FOIL back to see if you got it right. So you could either distribute the 4 over here and over here, and then multiply whatever you get by x minus 1, this term over here. Or what you could do is you could first do the FOIL of the x plus 1 and the x minus 1, and then distribute the 4, which is I think what we'll do. So we're first going to do the FOIL. We're going to FOIL x plus 1 and x minus 1. First is x times x, which is x squared. Outer is x times negative 1, which is negative x. Inner is 1 times x, which is x. And last is 1 times negative 1, which is minus 1. Let's not forget about the 4, so let's just bring it down here. And let's combine like terms within the parentheses. 4 times x squared minus x and positive x cancel out. We're left with x squared minus 1. Let's distribute the 4. 4 times x squared is 4x squared. 4 times minus 1 is negative 4. Since this is our original question, the answer is correct. Let's try another example. Let's say we have 36x squared minus 100. The first thing you always want to do before you use the method of the difference of two perfect squares, you want to see, is there a GCF? Can we factor out a GCF before we do anything? So let's use our calculator to see if there's a GCF of between 36 and 100. Math, scroll over to the num, down to number 9, enter, 36, comma, 100. Even though it's a negative 100, for this GCD thing on the calculator, we're not allowed to use negatives. So we just have to remember that it's a negative 100, and we're going to plug in a positive 100. and there's a 4. There's a GCF of 4. So let's factor out the 4. 4 times, what's 36x squared divided by 4? We could do it on the calculator. 36 divided by 4 is 9. 36x squared divided by 4 is 9x squared. Negative 100 divided by 4 is negative 25. You can do it on the calculator if you don't know that. And that is factored form. But is this completely factored? If the question asks you to factor completely, this would not be your answer. Why? Because inside the parentheses, you have no more GCF because you just took out a GCF, but you still have the difference of two perfect squares. 9x squared is a perfect square, and 25 is a perfect square, and they're separated by a minus sign, so that is the difference of two perfect squares. So let's bring down the 4. We don't want to forget about the 4. When we use the method of the difference of two perfect squares, we take the square root of the first term, so the square root of 9x squared is 3x, and then we add to that the square root of the second term, the square root of 25 is 5. And then we do this, we multiply that by the square root of the first term, which is 3x, and we subtract from that the square root of the second term, which is 5. And this would be the completely factored form of 36x squared minus 100. Let's check back to make sure we got it right. We could either first distribute the 4 over the first parentheses, then multiply what we get by the second parentheses, or we could first do the FOIL and then multiply by 4, and that's what we're going to do. We're going to first do the FOIL. So we're going to do first, 3x times 3x is 9x squared. Outer is 3x times negative 5, which is negative 15x. Inner is 3x times 5, which is plus 15x. And last is negative 5 times positive 5, which is minus 25. And we don't want to forget about the 4. We want to bring down this 4 from the beginning and combine like terms within the parentheses. Negative 15x plus 15x cancel each other out. We're left with 9x squared minus 25. Distribute the 4. 4 times 9x squared is 36x squared. 4 times negative 25 is negative 100. Is this our original question? And it is. Therefore, the answer is correct. Let's try another example. Let's say we have x to the 8th minus 81. First thing we always want to do is check, is there a GCF? Since there is no GCF, we're going to move on to the difference of two perfect squares. X to the 8th and 81 are both perfect squares, and they're separated by a minus sign, so we can use the method of the difference of two perfect squares. So we take the square root of the first term, the square root of x to the 8th is x to the 4th. We add to that the square root of the second term, the square root of 81 is 9. Then we take this, we multiply that by the square root of the first term, which is x to the 4th. We subtract from that the square root of the second term, which is 9. If the question asked you to factor completely x to the 8th minus 81, this would not be your answer, because if you notice, we still have the difference of two perfect squares within those parentheses. X to the 4th is a perfect square, and then 9 is also a perfect square. They're separated by a minus sign, so this is also the difference of two perfect squares. However, x to the 4th plus 9 is not the difference of two perfect squares, because x to the 4th is a perfect square, 9 is a perfect square, but they're separated by a plus sign, not a minus sign. So this term we just bring down, x to the 4th plus 9. But we have to finish factoring x to the 4th minus 9. To use the difference of two perfect squares, we take the square root of the first term, which is x squared. We add to that the square root of the second term, which is 3. Multiply that by the square root of the first term, which is x squared. Subtract from that the square root of the second term, which is 3. Now let's just look over our terms to make sure we don't have any more of the difference of two perfect squares. X to the 4th plus 9, this is not the difference of two perfect squares. X squared plus 3 is not the difference of two perfect squares. X squared minus 3, even though it's a difference, and even though x squared is a perfect square, 3 is not a perfect square, so it's not the difference of two perfect squares, and this would be your answer. Now you would always want to check to see if you got it right. And to do that, you would have to FOIL two of the terms. It doesn't matter if you FOIL these two and then multiply it by this one, or if you FOIL these two and multiply it by this one. We're not going to do it just because it would take a while, But if you want, you can FOIL and make sure we got it right. Your answer, whatever you get when you FOIL that and multiply that, you should get back over here.